This is an example of a hypothesis test for a population mean when sigma is unknown. Stan Deviat is a high school senior who is concerned about attending college because he knows that many college students require more than 4 years to earn a bachelor's degree. At alpha equal 0.10, test the claim of his guidance counselor who states that the mean time is greater than 5 years. Sample data consists of a mean of 5.15 years and a standard deviation of 1.68 years for 80 randomly selected college graduates. Because this is a test about mu, there are two choices. We can do a z-test or a t-test. We are going to use a t-test in this problem because we don't know the population standard deviation and the sample size is greater than 30, so the conditions are met to use a t-test. We need to set up the null and the alternative. The claim is that the mean time is greater than 5 years. So writing that in terms of mu, that's mu greater than 5. This is the claim. Because it does not contain the case of equality, it makes it the alternative. And in the null, I'll have the case of equality. The standardized test statistic is a t-value, and the formula is x bar minus mu over s, the sample standard deviation, over the square root of n. In the problem, the sample size is 80, the sample mean was 5.15 years, and the sample standard deviation was 1.68 years. Because we're going to get the critical value from the t-distribution, we're going to need the degrees of freedom, which is n minus 1, so the degrees of freedom will be 79. Plugging into this test statistic formula, I have 5.15 minus 5 over 1.68 over the square root of 80. What we observe minus what is claimed or what is hypothesized over the sample standard deviation divided by the square root of the sample size. Putting this into my calculator using parentheses, so the calculator will observe order of operations. Closing my denominator parentheses, I get a standardized test statistic of 0.799. To find the critical value, you'll either want to use your t-table or your inverse t function in your calculator if it has it. To find the critical value, and there is only one, because this is an upper tail test, the direction of the alternative indicates to me that this is an upper tail test. So we need our level of significance. Sketching a t-distribution, which is bell-shaped, putting a mean of 0 in the middle, and shading my upper tail of rejection. 0.10 is the amount of area in this upper tail. And looking at my t-table, I don't have, let's see, I've got 0.1 in that upper tail. That's how this table reads. Scrolling down to the degrees of freedom, it doesn't have 79 for my degrees of freedom. But 79 is close to 80, so as an approximation, I can use 1.292. I can use technology to get a better value for that critical value. Going to my distribution menu in the calculator, selecting option 4. It needs a cumulative area to the left of that critical value. If the area in the upper tail is 0.1, I have 0.9 amount of area. To the left of that, my degrees of freedom is set 79. And rounding to 3 decimal places, I get the same critical value. Looking at where the standardized test statistic is placed along this horizontal axis with respect to the critical value, we are in the fail to reject region. So the decision will be to fail to reject the null, meaning that the null is the quote-unquote winner. So to test the claim, the guidance counselors claim that the mean time is greater than 0.5 years. There is insufficient evidence to support that guidance counselor's claim. We can take a look at the p-value for this. I strongly recommend using technology to find the p-value for a t-test because the t-table is very limited. To get that, you want to go to your stat menu, right arrow over to tests, select the t-test, and we have the summary statistics for this problem, not the data in a list. Putting in the null statement of 5 years, our sample mean was 5.15. Sample standard deviation is 1.68. Sample size was 80. Changing the direction of the alternative to a greater than. Down arrow to calculate. And you'll see that our standardized test statistic rounded to 3 decimal places is the same. This p-value is 0.213. Where the p-value represents the area further to the right of that standardized test statistic. When our p-value is greater than or equal to our level of significance, the decision is to fail to reject the null. Again, there is not enough evidence to support that claim. And because the decision was to fail to reject the null, it is possible a type 2 error may have occurred.